Hi and welcome back to the new tutorial. In this video, we'll do static analysis of the side mill cutter. Let's start our tutorial. Before going to the analysis workbench, we need to change the visual appearance of this part. So change the appearance and select shading with material and apply the material. So I'm going to select metal and steel. Select the part and press apply material. Okay. So this is our steel metal or steel material. So we applied the steel metal. So in the part body you can see it's the steel. So now go to start, select analysis and simulation, select generative structural analysis workbench. When we open the analysis workbench, there is a new analysis case dialog box will be opened. Select static analysis and OK. So this is our graphical interface of analysis workbench. In the features tree, press this plus icon in the nodes on elements and double click on meshes. So resize the mesh size. So I'm going to give 1 mm and OK. Properties, it is a 3D model. Materials, we applied a material, it is the steel. Double click here, it will shows material is steel. Okay. In the static case, provide the boundary condition of this part. So in the restrainers, select clamp, select the whole face and OK. So this clamp is added to restrainer. So this is a clamp command. We fixed this inner hole. In the load command bar, select movement command. Select these faces. Movement should be in clockwise direction. So this is a clockwise. You can see the arrows. Movement rotational axis is X. Movement value is 10 Newton meter. So it is minus 10 Newton meter and OK. In the load command, select distributed force and select this top face. This is our axial load. Load is 10 Newton. Direction is X direction. So arrows should be this side. Value is minus 100 Newton and OK. Again select distributor force and select this face. This is a cutting face. So direction should be in Y direction. X is 0. Y is minus 200 Newton. So this is our cutting direction. Okay. We applied the boundary condition and select this compute command. OK. And yes. In image command bar, select second option. So this is our 1 measure stress. Maximum 1 measure stress is 1.93 e power 7 Newton meter square. The maximum one measure stress should be below the yield strength of the material. So our maximum one measure stress is 1.93 e power 7 Newton meter square. Go to material on analysis connection. It's a command. Here select metal and select steel. Right click properties and select analysis. So yield strength is 2.5 e power 8 Newton meter square. So our one measure stress is 1.93 e power 7 Newton meter square. So one measure stress is within the yield strength. So this part is applicable to manufacture. That's it for this video. We'll see in the next video. Thank you for watching.